Well, congratulations, we've made it to Chapter 6. This is the last chapter of the trimester. Today we're going to look at 6.1, Solving Systems by Graphing. So date over there and we will get started. So what is a linear system? Basically we've got this definition right here. It's a system of two linear equations is two equations put together. So you put two together, you call it a system. We can solve the system. What is the solution when you solve it? It's going to be an ordered pair that satisfies both equations. So we're going to work on three different methods to solve a linear system. Today we're just looking at graphing, and then there's two other algebraic ways where we will find the solutions to systems. So just to give you a visual of what we are talking about, these are three graphs of three different systems, and basically a system is two equations put together. So when you graph two equations, there's three things that could possibly happen. Maybe your lines will cross, and that point where they cross, that's the one ordered pair, the xy, that satisfies both equations. So this one, if your lines cross, you're only going to have one solution. You would want to say what that solution is. On this graph, it looks like, I'm kind of estimating a little bit, a -2, +2 to get to that one point right there. It's possible that you could draw two lines and they don't cross at all. You know, sometimes we have these parallel lines. If the slopes are the same, those lines would be parallel. Well, those two lines will never cross, which is why we would say that there is no solution. And the last thing that could happen when you draw two lines is maybe they end up being in the exact same spot. So because a solution is going to be any point that they share every single point on that line. So we'll say infinitely many solutions, or sometimes I'll just shorten that and say infinite solutions. It's a little sloppy, but you know what I mean. That word infinite is pretty important because lines continue forever in both directions. That means that there is an infinite number of solutions to this system right here. They share every single point forever and ever and ever and ever. So if you have an ordered pair, how can you tell if it's a solution to the system? So is this ordered pair a solution to this system? And what we're basically asking is this the point where your two lines cross? So to figure that out, all you have to do is take both lines, so we have 11x minus 2y equals 62, and plug in the x and the y. If you get a true statement for both lines, then it's a solution. So we're going to plug in the 11 times 4 minus 2 times a -9, and we want to know, I'm going to put a little question mark, does that equal 62? 11 times 4 is 44. -2 times 9 is a positive 18. And then 44 plus 18 is 62. So it worked. Now, all that tells us is that this ordered pair is on the first line. We don't know if it's also on the second line, so you do have to plug it into the other equation as well. So we have 3x plus y equals 3. Plug in the same x and y. So 3 times 4 plus a -9, does that equal 3? So you have 12 plus a -9. 12 plus -9 is 3, so it worked. Is 4 -9 a solution? Yes, it is. So when you're plugging in points to tell if they're solutions, if a no shows up here or a no shows up here, then it's just no to the whole question. So you have to get a yes and a yes to say yes to the whole system. All right, so we're going to do three graphs. The first one, make sure, we did a lot of graphing in Chapter 5, so we're ready for this. This first one, I'll kind of separate a little bit. We've got y equals x plus 3. It's in slope-intercept form, so we know our slope is 1 over 1, and our y-intercept is 0, 3. So when we graph that, start with the y-intercept up here at 3. You're going to go up 1 over 1, up 1 over 1, and you are just going to continue this pattern on both sides. And it's really important now that we're in Chapter 6 to fill up your entire graph with the points to draw a nice neat line. You'll make it a little thicker. Let's see. All right, so there's our first line. Hopefully yours is straighter than mine. All right, next one, we have y equals negative 1/2 x. So we're solved for y, so that means we can identify the slope is a negative 1/2. The y-intercept, sometimes this throws people off. If there's nothing right here, there's still a y-intercept. It just means that it was a 0 that simplified away. So our y-intercept is 0, 0. So we go to our graph. I'm going to zoom in on this one. There we go. Let's see. So, okay, so we're at 0, 0. And then the slope is negative 1/2. So I'm going down 1 to the right 2, down 1 to the right 2. And you fill up your whole graph. Already the slopes are different, so I can tell they're going to cross somewhere. Up 1 to the left 2, and that point right there, I can tell that that's where these two are going to cross. But I'm going to keep going. Up 1 to the left 2, and then we draw in our line. And the lines cross, so there is one solution, but we don't want to write just one solution. We have to tell what it actually is. So the solution is the ordered pair where your two lines cross, which will be the x is a negative 2 and the y is a 1. So we solved the system of equations by graphing to see where they cross. All right, so we're going to solve this system by graphing. That just means graph both lines. So the first line, it's already solved for y, so our slope we can identify is 1/2. The y-intercept is 0, 4. So when we graph this, we're at 0, 4 for the y-intercept. And then the slope is 1/2, so up 1 to the right 2. And fill in your entire graph. Go ahead and draw your line as best you can, nice and neat. All right, so there's our first line. Our second line, now you may notice that the second one, and hopefully we did notice, this is not solved for y. That means we have to do a little bit of legwork before we can graph this. So solve for y, we add x to both sides first. That cancels, so we have 2y equals x plus 8. And then you divide both sides by 2. So we have y equals x over 2, that's a 1x over 2, so 1/2 x plus 4. So you may notice right now that this is 1/2 x plus 4, and this is 1/2 x plus 4. Those are the same lines. Just to kind of be accurate about it, I'll go ahead and identify, yep, here's all that same information. When you graph it, it's going to be the same line. Up here at 4, up 1 over 2. And we can see these two lines share every single point. So what do we write for our solution? This is the one, if it's the same line, there are infinite solutions. All right, last slide. So we have two equations in our system. Looks like we have to solve both of those for y. So the first one, go ahead and, there we go. First one, we have to subtract the 2x to get the x to the other side. Well, and that's kind of nice. That does enough to solve our equation. Y equals negative 2x minus 1. This is ready to graph. Our slope is a negative 2 over 1. Y-intercept is 0, negative 1. So when we graph this, starting with 0, negative 1, and then slope of negative 2, so down 2 to the right 1, down to the right 1, and then backtrack the other way. Draw in your line. Okay. Next we have negative 4x plus 2y equals negative 5. It's not in slope-intercept form, so we don't know how to graph it until we get that y alone. So we're going to add 4x to both sides. Negative 2y equals 4x minus 5. Divide by negative 2. All right, so we have y equals 4 divided by negative 2 is negative 2x. And then a negative 5 over a negative 2 is a positive 5 over 2. So we'll talk about that in a second. Slope is negative 2 over 1. Y-intercept is 0, 5 halves. So that 5 halves, we want to know where that is on a graph. Well, if you just type that into your calculator, you can see that that's a 2.5. So that's easy enough for us to find. One thing you might notice is you have in the top equation a slope of negative 2 and the bottom a slope of negative 2. So these lines have the same slope, which means they're parallel. Because the y-intercepts are different, they're not the same line, so these are parallel lines. So when we go to graph, your y-intercept is up here at 2.5, which is right here, halfway between 2 and 3. Now when you do your slope of negative 2 from that spot, you're going to go down 1, 2, and you see how that puts us between the 0 and the 1, and then over to the 1 right, over 1 to the right. Sorry, this is kind of an annoying graph. Down 2 to the right 1, so all of these points we're plotting are kind of halfway in between our lines. Down 2 to the right 1. And then we get the other side, and we can go ahead and draw in our line. So what is your solution if your two lines are parallel? We can't just write parallel, we have to understand what that means for a system. So if the lines do not cross, that means there is no solution. And that's solved by graphing.